Sorry, YouTube, I didn't have my mic on. So you can see some of these derivatives up here. So our cosecant is negative 1 over x roots of x squared minus 1. So what are the, if you memorize this one, and this one, then you're good to go, right? Because the others are just negative. And to be clear, on the test, I don't really care about the negative ones. The most common ones that you see, possibly on the AP exam, are going to be this one and this one. Don't know if I've ever seen that. We'll see. How about this? What, again, is the derivative of natural log of x? That's an absolute must. You cannot forget that. You forget this, probably not as that big of a deal. Not going to cost you too much. Let's do some basic derivatives. We want to find, for the function, and I'm going to rewrite it just so we all understand, cosine inverse of e to the x. Can somebody guess what rule I use to find the derivative of cosine of inverse of e to the x?
Chain rule.
Is it the product or the chain? Which is it?
Chain.
Yeah, it's not cosine inverse times e to the x. It's cosine inverse of e to the x. See the difference? If you had e to the x times cosine inverse of x, then that's the product rule. But because e to the x is what you're taking the cosine inverse of, then that's the chain rule. So let's do the chain rule. What goes on the outside? Cosine inverse of u. What goes on the inside? E to the x. Wish I knew what the derivative of e to the x was. Oh, isn't that nice? And then, what was the cosine inverse derivative? Yeah, so there's not a whole lot of simplifying that really ever happens. The algebra really doesn't get messy at all in these situations. This is e to the x over 1. So if you're going to multiply these two, what's going to be in the numerator for the derivative? Good. And then if you plug e to the x into here, what happens if you take e to the x and you square it? You get, yeah, so it's just square root of 1 minus e to the 2x. That's it. No, it's not.
It's going to get worse.
Not that much. We good?
This one you use product, right? And chain rule, it's a chain rule.
This is a chain rule. There's no multiplication. It's just tangent inverse of. So I got arctan of u. What goes on the inside? What's the derivative of 4 minus 2x? Negative 2. What's the derivative of arctan of u? Very common for people to put an x there. Again, I'm putting a u for the sake of notation, because when I see u is kind of that universal letter that we use in mathematics for substitution. That's why, you can substitute something back in. It helps us remind us that we plug something in there. When I multiply these, what do you get on the top? Sure, yep, negative 2 over 1 plus. Yeah, that's fine. You don't have to multiply it out in combined terms. It's fine just like that. I don't care. You good? Flip it over. How about here? Chain rule. Good. You try it. You do this one on your own. You're so smart. I know you can do it. Did you get this far in the setup?
Yeah.
So then, how I want to write this. So watch what happens. This is kind of a cool thing. I take that root of x, I plug it into here, right? So you can see on the bottom, you get root of 1 minus just x, right? And then what's on the outside? 2 roots of x. So if you want to distribute that root of x through, that's fine. You can write it as 1 over 2 roots of x minus x squared. I don't care. I just ask that you know that those two are the same, right? So that way, if you see it expressed one way on the AP exam, then you know what you're doing. We good? Okay.
Hold on. I need to get that down.
Did she get it, Linz? Is there a question on this? Yes, no? Went once? Twice, 3 times. There we go. Okay, let's check out number 4. I think number 4 looks basically impossible.
Yeah, me too.
I mean, if you look at it, it says x times the natural log of, this is an arc cotangent, so cotangent inverse of x. Looks absolutely ridiculous. But it turns out it's not that bad. You tell me, what rule do I use? Product and chain. Excellent. So what we have here is, as you read it, it says x times the natural log of. So product rule with the chain rule. Let's set up f and g. So we have f prime of x is equal to, what's the derivative of f? That was easy. Times g. G is natural log of arc cotangent of x. Then what? Plus, then I got to do the chain rule on that guy times x, right? Okay, just write the x first. Okay, x times. Now let's use the chain rule. Natural log of u and arc cotangent of x. Derivative of natural log of u. 1 over u. Derivative of arc cotangent. Good. Negative 1 over 1 plus x squared. So when I multiply these two together, what's going to be in the top? And in the bottom, I'm going to have arc cotangent of x times 1 plus x squared. Yeah? So that thing is what goes right there, right? And if I multiply it by x, does the x go on the top or the bottom? Goes in the top. So therefore, our derivative, f prime of x, is equal to the natural log of cotangent inverse of x plus, or should I do minus? Now let's do minus x over, I think we had cotangent inverse of x times 1 plus x squared. We're not asking for any simplifying. There really is no simplifying. The result is not pretty, is it? All right, 2 more. You guys are doing great. This one's kind of a fun one. All right, what rule? Chain, good. Cosecant inverse of u and e to the 3x plus 1. Thank you, good job. What's the derivative of cosecant inverse?
1 negative 1 over x times
So again, I'm going to replace the x variable with u. Notice how many u's do you have in that expression? You have 2. So how many places do you have to plug e to the 3x plus 1 into? Yeah, so this e to the 3x plus 1 thing, and I know we still got some work to do, but it's going to go both in there and it's going to go there. Okay? All right, now let's focus on the derivative of e to the 3x plus 1. And this is where on your test people kind of start to fall apart here. They just want an easy result. How do we find the derivative of e to the 3x plus 1? That's another chain rule situation. So e to the u, 3x plus 1. Love the derivative of e to the u. And we get 3. So what's the derivative? 3e to the... Good. Ready to multiply these two together? And it works out really, really nice. What's going to be on the top?
3e.
Negative 3e to the 3x plus 1. Notice on the bottom we have to write u first, which is root of. And then if we take this and we square it, what's the new exponent going to be? 6x plus 2. Good. E to the 6x plus 2. And we have that minus 1. What do you notice? Yeah, exactly. You have an e to the 3x plus 1 on the top, and you have an e to the 3x plus 1 on the bottom. So the result is that negative 3 over the square root.
Oh.
Saw the eyes. They started to go like this instead of like that. That was my sign. I've become a lot better reading eyes than I have at reading faces lately. Okay, last one, number 6. How does it look? Bad? I agree. It looks horrible. But I really don't think it's going to be that bad. I think it's actually going to work out pretty cool. And I like tangent inverse. That's a nice one. Because what's the derivative of tangent inverse? 1 over 1 plus x squared, right? Like, I think that actually works out quite nice. What rule do you think we use? Chain. Let's set it up. By the way, you guys, you're really doing excellent. You really are. Taught calculus for a long time. And when I look at what you've gone through over the last 15 months, you're doing very well. We are behind. You are doing very well. We're getting caught up. I am transitioning in the material. You're doing a good job. Hi.
Hi.
How we doing?
Good. How are you?
Scarf pump. All right. Here I've got x minus the root of 1 plus x squared. Derivative of tangent inverse. What's the derivative of x? How do I find the derivative of the root of 1 plus x squared?
Another chain.
Yes.
So how did you first get the root of this?
Right there?
Yeah.
So I'm looking at this guy, and I'm saying the square root of u is my outer structure, and then 1 plus x squared is on the inside.
So you just move the square to the u? Or the square root of u?
So I'm saying this is the inside, so this thing's u, and 1 plus x squared there. Just like if you had like sine of 4x, you would have sine of u and 4x.
Okay.
Yes?
Yeah.
So I just take whatever the inside is, I replace it with u. That better? Okay, derivative of 1 plus x squared. 2x. Derivative of the root of u. Awesome. So when I multiply these two together, what's going to happen? 2's are going to cancel. What's going to be in the numerator? X. And in the denominator, I have the root of 1 plus x squared. just write it out. 1 over 1 plus this thing squared, right? X minus root of 1 plus x squared, quantity squared. I plugged that thing in for you. Now I got to times that, right? Times 1 minus x over the root of 1 plus x squared. That's it. Does it look ridiculous? A remarkably difficult derivative to find. Again, if we go back to our days of f of x plus h minus f of x over h. So again, to give you a level of difficulty, I wouldn't, forget about me not being able to get that problem right. I wouldn't even have, I don't have a chance. Like I would stay there for a month, I would have no idea what I'm doing. But yet with the chain rule, boom, took us 2 minutes. Good job. Take out your homework.